Hello students, welcome to the lecture on Philosophies of Quality Management, and after this lecture we will be able to learn the following objectives. Discuss the contribution of ARMAND v. FEIGENBAUM, explain contribution of KAORU ISHIKAWA, describe contribution of Shigeo Shingo, define contribution of W. Walter A. SHEWHART, describe concept of quality circle, understand the Japanese 5S principle. Let's start with the introduction. The concept of quality is at the core of many of our ideas about effective management and leadership, and programs like Total Quality Management and Six Sigma have been at the heart of many companies' success.
Hello class, today we will overview Six Sigma.
Professor Siegfried, who developed Six Sigma?
Well Jack, Six Sigma is a business management strategy originally developed by Motorola in the United States of America in 1986. Today, it is widely used in many sectors of industry.
Professor, just what does Six Sigma do?
Well Jack, Six Sigma seeks to improve the quality of process outputs by identifying and removing the causes of defects, errors, and minimizing variability in manufacturing and business processes. It uses a set of quality management methods, including statistical methods, and creates a special infrastructure of employees within the organization. Employees become trained as black belts, green belts, etc., and are experts in these methods. Each Six Sigma project carried out within an organization follows a defined sequence of steps and has quantified financial targets, cost reduction and/or profit increase. The term Six Sigma originated from terminology associated with manufacturing, specifically terms associated with statistical modeling of manufacturing processes. The maturity of a manufacturing process can be described by a sigma rating indicating its yield, or the percentage of defect-free products it creates. A Six Sigma process is one in which 99.99966% of the products manufactured are statistically expected to be free of defects, 3.4 defects per million. Motorola set a goal of Six Sigma for all of its manufacturing operations, and this goal became a byword for the management and engineering practices used to achieve it.
Professor, are there problems with companies adopting a Six Sigma strategy?
The only danger, Jack, is that companies can be so focused internally on process improvements and improving operational cost savings, they lose focus on growing top-line sales. Well Jack and Ned, that should do it today for Six Sigma.
We know now that quality needs to be built into every level of a company and become part of everything the organization does. A new business philosophy. We owe this informative thinking to Dr. W. Edwards Deming, a statistician who went to Japan to help with the census after World War II. Deming also taught statistical process control to leaders of prominent Japanese businesses. After applying Deming's techniques, Japanese businesses like Toyota, Fuji, and Sony saw great success. Their quality was far superior to that of their global competitors, and their costs were lower. The 14 points of Philosophies of Quality Management. Create a constant purpose toward improvement. Adopt the new philosophy. Stop depending on inspections. Use a single supplier for any one item. Improve constantly and forever. Use training on the job. Implement leadership. Eliminate fear. Break down barriers between departments. Get rid of unclear slogans. Eliminate management by objectives. Remove barriers to pride or workmanship. Implement education and self-improvement. Make information everyone's job. Let us discuss contribution of ARMAND v. FEIGENBAUM. ARMAND Welland FEIGENBAUM, born 1922, is an American quality control expert and businessman. He devised the concept of total quality control, later known as Total Quality Management (TQM). His contributions to the quality body of knowledge include: total quality control is an effective system for integrating the quality development, quality maintenance, and quality improvement efforts of the various groups in an organization so as to enable production and service at the most economical levels which allow full customer satisfaction. The concept of a hidden plant, the idea that so much extra work is performed in correcting mistakes that there is effectively a hidden plant within any factory. Accountability for quality. Because quality is everybody's job, it may become nobody's job. The idea that quality must be actively managed and have visibility at the highest levels of management. Awards and honors of ARMAND FEIGENBAUM. First recipient of ASQ's Lancaster Award. ASQ 1965 Edwards Medal in recognition of his origination and implementation of basic foundations for modern quality control. National Security Industrial Association Award of Merit. Member of the Advisory Group of the U.S. Army. Chairman of the System-Wide Evaluation of Quality Assurance Activities of the Army Materiel Command. Consultant with the Industrial College of the Armed Forces. Union College Founders Medal. Fellow of the American Association for the Advancement of Science. Life member of the Institute of Electrical and Electronics Engineers. Life member of the American Society of Mechanical Engineers. Thus, a total quality system is defined as the agreed company-wide and plant-wide operating work structure, documented in effective, integrated technical and managerial procedures for guiding the coordinate actions of the people, the machines and the information of the company and plant in the best and most practical ways to assure customer quality satisfaction and economical costs of quality. Operating quality costs are divided into prevention costs including quality planning, appraisal costs including inspection, internal failure costs including scrap and rework, external failure costs including warranty costs, complaints, etc. Reductions in operating quality costs result from setting up a total quality system for two reasons. Lack of existing effective customer-oriented customer standards may mean current quality of products is not optimal given use. Expenditure on prevention costs can lead to a several-fold reduction in internal and external failure costs. The new 40th anniversary edition of Dr. A.V. Feigenbaum's book, Total Quality Control, now further defines TQC for the 1990s in the form of 10 crucial benchmarks for total quality success. These are that quality is a company-wide process. Quality is what the customer says it is. Quality and cost are a sum, not a difference. Quality requires both individual and a team zealotry. Quality is a way of managing. Quality and innovation are mutually dependent. Quality is an ethic. Quality requires continuous improvement. Quality is the most cost-effective, least capital-intensive route to productivity. Quality is implemented with a total system connected with customers and suppliers. Let us discuss contribution of KAORU Ishikawa. Total Quality Management, or TQM for short, is defined an operational philosophy committed to customer satisfaction and continuous improvement. The TQM is committed to being the best in all functions through the use of quality and excellence. Founded by the late W. Edwards Fleming, TQM's primary goal is to reduce costs and improve the quality of company's product. The TQM has four main objectives: better, less variable quality, quicker, less variable response to customers' needs, greater flexibility in adjusting to customers' needs, and lastly, lower cost through quality improvement and non-value adding work. About KAORU Ishikawa, Dr. KAORU Ishikawa was the developer of the concepts of quality circles and the cause and effect diagram, commonly known as fishbone diagram or the Ishikawa diagram. Ishikawa was born in the city of Tokyo on July 13, 1950. He lived to be the age of 73 when he passed away on April 16, 1989. He earned his degree in engineering from the University of Tokyo. Ishikawa's philosophy. Ishikawa's philosophy focused on transforming the workplace. He wanted people to begin to take pride in the quality of their work. Oftentimes, in his book, What is Total Quality Control?, he mentions the fact that top management cannot be disconnected from the total quality management of the company. He wrote about challenging managers not only to implement the quality into their company, but to keep the mentality of continuous improvement. Ishikawa's contributions. Over Ishikawa's career, he has greatly impacted the world of total quality. We will discover the several ways he did so. The first contribution includes enhancing Deming's PDCA model or Plan, Do, Check, Act model. He transformed it into a 6-step plan. The 6 steps include determine goals and targets, determine methods of reaching goals, engage in education and training, implement work, check the efforts of implementation, and lastly, take appropriate action to accomplish goals and targets. Let us now discuss the contribution of Shigeo Shingo. At Utah State University's 14th Annual Productivity Conference in the spring of 1989, where Shigeo Shingo was receiving an honorary doctoral degree. At Utah State University's 14th Annual Productivity Conference in the spring of 1989, where Shigeo Shingo was receiving an honorary doctoral degree, and at the same time lending his name to the Shingo Prize for Operational Excellence. Speaking through a translator, Dr. Shingo began with a short greeting to the audience of about 500 attendees, mostly educators, and then launched into an explanation of his SMED, Single Minute Exchange of Dice, system. Every changeover, he declared, can be reduced by 59/60ths. Let us now talk about the contribution of Walter A. Shewhart. Walter A. Shewhart was founding editor of the Wiley series of mathematical statics, a role that he maintained for 20 years. Originally an engineer and statistician, Walter A. Shewhart is all known as the true father of modern quality, whereas W. Edwards Deming was his student and spiritual son. Shewhart introduced the concept of statistical process control (SPC) in manufacturing. More on Walter Shewhart. It was the inspection engineering department of the Western Electric Company at Hawthorne at Shewhart joined in 1918. He worked there on statistical tools to examine when a corrective action must be applied to a process. His writings were on statistical control of industrial processes and applications to measurement processes in science. The control chart techniques which he developed have been widely adopted. Dr. Shewhart prepared a little memorandum only about a page in length. About a third of that page was given over to a simple diagram which we would all recognize today as a schematic control chart. Let us discuss the concept of quality circle. Quality circle QC is a formal, institutionalized mechanism for productive and participative problem-solving interaction among the employees of an organization. The QCs consists of small group of employees from all levels of the existing hierarchical structure within an organization, voluntarily involved in the process of identifying, analyzing, and formulating solutions to various technical, manual, and automation-related problems encountered in daily work life. The following could be grouped as broad intentions of a quality circle: to contribute towards the improvement and development of the organization or a department, to overcome the barriers that may exist within the prevailing organizational structure so as to foster an open exchange of ideas, to develop a positive attitude and feel a sense of involvement in the decision-making processes of the services offered, to respect humanity and to build a happy workplace worthwhile to work, to display human capabilities totally and in a long run to draw out the infinite possibilities, to improve the quality of products and services, to improve competence, which is one of the goals of all organizations, to reduce cost and redundant efforts in the long run. With improved efficiency, the lead time on conveying of information and its sub-assemblies is reduced, resulting in an improvement in meeting customers' due dates. Customer satisfaction is the fundamental goal of any library. It will ultimately be achieved by quality circle and will also help to be competitive for a long time. Characteristics of a QC circle. Small group. The circle is normally composed of 3 to 10 volunteers who come from the same work area and are under the same supervisor. Continual control and improvement in the quality of work, products and service. QC continues to look for opportunities for improvement from the time they receive their inputs to the time they deliver their product or service to their customers. Autonomous operation. They are free to choose the problems to solve. They identify what data to collect in order to better understand why the problems exist, and their members analyze the problems causing among themselves, though they sometimes consult other departments that affect their work. Utilization of quality control concepts, tools and techniques. The circle works with the aid of data throughout its problem-solving activities. Self-development. A QC circle contributes not only to the development of a sound working environment but also to the enhancement of individuals' abilities and potentials. Quality circle organization. The introduction of QC program is managed by the QC Steering Committee and QC Office. QC Steering Committee may consist of the following officials: DTO Chairman, DP Co-Chairman, GM Production, GM HRD, GM E&M, GM Excavation, GM Materials, GM Safety, GM IED. Roles of the QC Steering Committee. Define the ultimate goal of the QC program in the company. Formulate a master plan for the installation of the program. Formulate a plan on how to recognize the exemplary performance of circles, members, leaders and facilitators. Formulate a plan on how to monitor and evaluate the components of the QC program. Formulate a budget for the program and identify sources of funds. Define qualifications and functions of facilitators. Act on concerns that may be raised by the QC office, the facilitators, or the QCs themselves. Evaluate the overall status of the QC program, including training, rewards and recognition, promotional activities and procedures for evaluation of QC case studies and activities. Formulate corrective and preventive actions based on findings in the evaluation. QC Office. The following officials may hold the office of QC: GM Manpower, DGM IED, DGM HRD. Roles of the QC Office. The QC Office is responsible for the day-to-day management of the QC activities in the company. Specifically, the office implements policies and plans formulated by the QC. Facilitators. One facilitator for each mining, E&M, excavation, finance and personnel in each area. Facilitators are normally managers and experienced engineers and comprise a key element that greatly influences the success of the QC Circle program. especially at the beginning of its development. Training, guiding leaders. Coordinating training courses, working closely with the department heads. Assist leaders in their QC activities. Motivating QC leaders and members. Arranging QC case presentations. Coordinating QC activities. Periodic participation in QC proceedings. QC leaders. Participation in the basic activity of a QC is normally on a voluntary basis, yet there are several ways in which circle leaders are actually selected. Circle leaders must be selected carefully, particularly when it is at the beginning of its activities. Basic functions of a circle leader. Conducting QC circle meetings. Deciding roles of individuals and proceeding of QC activity. Learning QC tools and techniques. Disseminating what is learnt in trying to improve members' abilities. Establishing annual activity plan. Encouraging members. Participating in the industry-wide conventions, training, coordination meetings. Studying about QC activities and disseminating the knowledge. Seeking advice and support from the QC office on behalf of its members. Quality circle process. Colliery manager, colliery engineer, shift in charge submits an implementation plan. Colliery manager, colliery engineer, shift in charge ask for volunteers. Leader registers the QC circle. Leader trains members. Identification of pilot circle project. QC presents case to management. Pilot circle evaluated. Execution of QC project. Reward and recognition to the QC. 7 QC tools. The 7 QC tools are used to collect, summarize and analyze data, quantitative and qualitative. Whereas basic techniques such as brainstorming, the why approach, affinity diagrams, 5S, 3MU, 5W1H and 4ME are used to assist members to think creatively. The 7 QC tools: stratification, Pareto diagrams, cause and effect diagrams, ISHIKAWA diagrams, graphs, check sheets, histograms, scatter diagrams, control charts. 5S is the acronym for 5 Japanese words: Siri, Siton, Siso, Siketsu and Shitsuke, and which signify order, cleanliness, purity and commitment. The principles underlying a 5S program appear to be common sense, and they are, but until the advent of 5S, many businesses ignored these basic principles. There is an order and logic to how 5S is carried out, which is Siri or sorting. Siri means sorting through everything in each work area. It requires keeping only what is necessary. Siton or systematize. This is the next step. It requires organizing, arranging and identifying everything in a work area for efficient retrieval and return to its proper place. CISO or shining. Once everything from each individual work area to the entire facility is sorted and organized, it needs to be kept that way. Siketsu or standardize. Siketsu ensures that the first 3 steps of 5S program continue to be effective. The good practices developed in the first 3 steps need to be standardized. Shitsuke or self-discipline. This implies continuous training and maintenance of standards. The organization must build a formal system for monitoring the results of the program. A follow-up is a must for the 4 steps to continue to be practiced. Now in the end, let us summarize what we have learned in this lecture. Quality is seen as having become the single most important force leading to organizational success and company growth in national and international markets. The TQM is committed to being the best in all functions through the use of quality and excellence. Founded by the late W. Edwards Deming, TQM's primary goal is to reduce costs and improve the quality of the company's product. Ishikawa's philosophy focused on transforming the workplace. He wanted people to begin to take pride in the quality of their work. The circle is normally composed of 3 to 1 volunteers who come from the same work area and are under the same supervisor. Participation in the basic activity of a QC is normally on a voluntary basis. Yet, there are several ways in which circles leaders are actually selected.